Okay, in this video we are going to work on how to simplify square root numbers and expressions by using product property in square roots. Okay, let's see. Okay, this is the product property of square roots. Now look at here, this statement. Now it says if two numbers a and b is multiplied inside the square root, then you can write them separately in two square roots as a product. This means, let's give an example. If you have square root of, say, 8, you can say this is square root of 4 times 2. So you can write it as square root of 4 times square root of 2. See, you can separate the square roots. What is more, here square root of 4 is 2, because 4 is a perfect square number. Since 2 squared is 4, square root of 4 is 2. So you have 2 times square root of 2. This is how we simplify square root expressions, as in here this is square root of 8 and we end up with 2 square root of 2. Another example, let's look at square root of 12. Now we can say this as 3 times 4. So we can write it as square root of 3 times square root of 4. Again, square root of 4 is 2. Now let me show how it becomes 2. We can write square root of 3 times square root of, well, 4 is 2 squared, right? So I can write 2 squared instead of 4. Now here, what happens is, you cancel the square root and the square, so at the end you have square root of 3 times 2, which we write 2 square root 3. So we use the product property to simplify the square root expressions. Now let's see some more examples. Now here we have square root of 54. Now it's not easy to find perfect square numbers in such numbers like 54. So if you can't figure it out, you can go through prime factorization. Remember that we do the following. For 54 we start dividing by prime numbers. What were the prime numbers? 2, 3, 5, 7, 11. So it goes on like that. These are the prime numbers, and if we start dividing these numbers to prime numbers, we do prime factorization. Okay, now 54 is an even number, hence I can divide it by 2. Divided by 2, 54 is 27. Now 27 is not even, so I should try 3 instead of 2. If I divide by 3, I get 9. Dividing by 3, I get 3. And then I divide once more by 3 and get 1. Now I do this until I get 1. Now the idea here is, if you group these two 3's, you have 3 squared here. So you can write square root of 54 as square root of 3 squared times 2 times 3. And by product rule you can separate the square root. So it will be 3 squared times square root of 2 times square root of 3. Here you can cancel square root and square out, hence you have 3 only. Now for these two numbers, square root of 2 and square root of 3, there is nothing else to do but multiply to get it into a more simpler form. So it will be 3 times square root of 2 times 3 is 6. Again, here we use the product property in reverse order. So this is the simplest form of square root of 54. Now let's look at square root of 180. For 180, let's do prime factorization. So I start dividing by 2, I get 90. Dividing by 2, I get 45. Now I have to divide by 3, so I have 15. Dividing by 3, I have 5. Dividing by 5, I get 1. So I'm done. Now let's have our groups. This is 2 squared, this is 3 squared, and there is only one 5 there. So I'm going to write like this. I can directly write in separate square roots format. So it will be 2 squared times square root of 3 squared times square root of 5. Now here, 2 squared and 3 squared will be out of the square root as we cancel the square roots and squares. So it will be like 2 times 3 times, well, for square root of 5, we cannot cancel the square root, so we keep it. So this becomes 6 square root of 5. This is how we simplify square root of 180. So as a summary, we can say that if we want to simplify numbers and square roots, like square root of 54, square root of 180, we have to write those numbers as product of their prime factors, so that we can group them to form some factors squared to cancel the square and the square root, and then simplify the expression. Now, there is a trick in here. If you can see that root 54 is equal to root 9 times 6, then you don't need to do prime factorization. You can say square root of 9 times square root of 6 by product property. Then you know that 9 is a perfect square number. So you can take the square root and say this is 3 square root of 6. And here it is not easy to see, but if you see that square root of 180 is nothing but 36 times 5, then maybe you can say 36 in square root times 5 in square root. And since 36 is a perfect square number, which when you take the square root you get 6, you have 6 root 5 without doing prime factorization. So if you know the perfect square number inside the given number, then you can simplify this number without going through prime factorization. Now look at these examples. Now here, this is square root of 5 times square root of 10, and well, for square root of 5 you cannot do anything because it is a prime number already, but for square root of 10 you can write it as a product of 2 and 5, so it will be square root of 5 times square root of 2 times square root of 5. Now this part is for the square root of 10. Now you see you can rearrange this and write square root of 2 times square root of 5 squared, because you have 2 5s in the product. So since you have 5 squared here in the square root, then you can cancel them. So you will have, as a result, 5 square root of 2. This is how you simplify. For this example, we have square root of 6 times square root of 8, which we can write, for square root of 6 it is square root of 3 times square root of 2, times, for 8 we can say square root of 2 times square root of 4, for example. Then we can rearrange so that it will be square root of 3 times, now you see there are 2 square root of 2's, so you can write it as square root of 2 squared, times 4 is nothing but square root of 2 squared. Now here, the square roots and the squares cancel each other, then you have 2 here, 2 times 2 is 4, so you have 4 square root of 3 at the end. Okay, Now is your turn. Please solve these questions and show me.